it will give equal shares to all the virtual machines. However, you as an administrator, you can control the resources. You can give more resources to a specific virtual machine which requires more resources, and maybe certain virtual machines require normal resources, maybe certain virtual machines require low resources. So that can be configured by controlling the virtual machine access to the given resources, and there are certain parameters which can be configured on a virtual machine. Using those parameters, you can control the resource allocation to specific virtual machines. Now, what are those parameters? Parameters are limit. If I set a limit on a virtual machine, then that virtual machine will not be able to utilize the resource beyond that particular limit, cannot exceed this value. Then I can also reserve certain amount of resources for my virtual machines. Let us say, for example, I've configured a virtual machine with 4 GB RAM. Out of 4 GB, I want to reserve 1 GB to my virtual machine. When I reserve 1 GB RAM to my virtual machines, that 1 GB is always available to that virtual machine, whether the virtual machine utilizes that 1 GB or not. So whenever you reserve something to a virtual machine, if that reservation is not available, then the virtual machine will not start, guys. Keep that in mind. So reservation, I can reserve a specific resource to a specific virtual machine. In the same way, the parameter is shares. Shares are nothing but it's a guarantee that a certain amount of resources are being granted for a virtual machine. Now let me show you how we can allocate specific resources to our specific virtual machines by allocating resources. I'm connected to my vCenter server. Now let us say this is my virtual machine. I want to allocate specific resources. Right click this virtual machine, click on edit settings, and here you find multiple tabs. Go to this resources tab here. Here if you see, you find CPU, and just now I've shown you what are the parameters which control the resources, limit, reservation and shares. You find here limit, reservation and shares. Now everything is a share here. For example, I told you every virtual machine is considered as equal. That's the reason why it is showing you normal shares. For example, this virtual machine is very important to you. Shares, you can give high shares to this virtual machines. And reservation would be in megahertz per CPU and megabytes in memory. Now here, if we want to reserve something, CPU to this virtual machine, I can reserve it. Okay, and limit. If I set a limit, here by default is unlimited, but you can also set a limit for a specific virtual machine. The same way I can allocate resources in memory. Okay, so normal shares, high shares, and what is say low shares. In the same way I can reserve something. 512 MB is the reserve for this virtual machine, and limit is unlimited. In this way you can allocate resources to individual virtual machines. However, allocating resources to individual virtual machines, if your infrastructure is very large, is very difficult. Let us say you have 500 hosts, and on each host you have 10 virtual machines. Then allocating 5,000 virtual machines to specific resources is a difficult task. So rather than doing that, what I can do is that I can create resource pools, something called resource pools. What are resource pools? Resource pools are nothing but logical containers by which I can manage CPU and memory resources. So logical abstractions. In other words, in simple way, is that resource pools are nothing but quotas of CPU and memory. I can create a quota of CPU and memory, and this quota can be given to a group of virtual machines. So what is the advantage of resource pools is that it allows administrators to divide and allocate resources to a group of virtual machines. The advantage of resource pool, rather than allocating individual resources to individual virtual machines, I can group certain virtual machines and I can allocate certain quota to that virtual machines. This quota is called as resource pool. It is an abstraction, logical abstraction, it's a logical container of CPU and memory resources. Now let me give an example of how resource pools can be used. Let us say your organization has 4 departments. Let us say finance, marketing, production, and some other department. Now, finance department gives most of the revenue to your organization. Let us say it gives 60% of the revenue. So now you can allocate 60% of the resources to the finance department virtual machines by creating resource pools. I can create a resource pool for finance department and allocate 60% of the resources and place all the virtual machines associated with finance department into it. So in this way, I can divide and allocate resources to virtual machines. In the same way, let us say marketing department gives 20% of the revenue, so you want to allocate 20% of the resources to it. You create a resource pool for marketing and give 20% of the resources to it, and place those virtual machines into it, and those virtual machines will get 20% of the resources. In the same way, production department, let us say it gives 10% and the other department gives 10%. So you can create resource pools for them and allocate 10% resources for them. So this is how we can logically create resource pools, resource quotas of memory and CPU and allocate these resources to group of virtual machines. So what are the attributes by which I can control resources and allocate resources to the resource pools? There are 4 attributes: shares, reservations, limits, and expandable reservations. Now, when it comes to shares, guys, I'll give you an example so that you don't get confused with shares. Now here, I'm talking about CPU now. Let us say I have 100 rupees. How many shares can I create of 100, guys? How many shares?
Each one.
Suppose I have 100. Suppose I have 100 rupees, how many shares?
100 shares.
Okay. Anything else?
I say 10.
It depends on my unit what I decide. If I say 100 rupees, my unit is 1 rupee, then 100 shares. If I say my unit is
10.
Yep, it depends on the unit what I say, right?
Yeah.
If I say unit is 50 paisa, then I get 200 shares. If I say my unit is 25 paisa, I get 400 shares. If I say unit is 10 paisa, I get 1000 shares. If I say unit is 1 paisa, I get 10,000 shares. If I say unit is 0.0001 paisa, whatever the calculation it may be. Okay, so here when I say that CPU is converted into shares, how many shares it is converted into we cannot say. But how many shares we are allocating to a resource pool or to a virtual machines, that I can say. So here, these are the parameters, guys, or the attributes by which I can allocate resources to the resource pool: shares, reservation, limits, and expandable reservation. Okay, we'll discuss this now. Okay, now before I show you how to create this resource pool by creating these attributes, let us try to understand the concept of shares. If you see this screen right now, I have a host with a CPU capacity of 10,000 megahertz. The meaning is it is approximately 10 gigahertz and a memory of 32 GB. Now here I am creating a resource pool for finance department. And what are the attributes? What are the parameters? Here the parameters are shares, reservation, limits, and expandable reservation. Okay, so here I have given CPU shares 1000. I have reserved 1000 megahertz. I have given the limit that 4000 megahertz. Expandable reservation, yes. Okay. Now out of that finance pool, I have created another 2 resource pools. One is finance production virtual machines, the other one is finance development virtual machines. For finance development virtual machines, I gave 2000 shares. For finance production virtual machines, I gave 1000 shares. Now you need to understand here. My finance pool actually has only 1000 shares. But how come I am able to allocate 2000 shares to finance development virtual machines and 1000 shares to finance production virtual machines? Are you able to understand this? I have only 1000 shares on finance pool, whereas I have created Another resource pool out of finance pool, finance production virtual machine 1000 shares, finance development virtual machines 2000 shares. How is this? How I am able to give 2000 shares and 1000 shares, whereas I actually have only 1000 shares?
Here reservation is 0, there it is 250.
No. Here, when I say shares, try to understand from the perspective of ratio. Okay? That means here, if you keenly observe, 1000 shares, this 1000 shares is coming from the host. Okay? Out of this 1000 shares, I am giving 1000 shares to finance production virtual machines. Out of this 1000 shares, I am giving 2000 shares to finance development virtual machines. What is the meaning of it is that out of this 1000 shares, finance production virtual machine resource pool is getting 1 by third of resources, and finance development virtual machine is getting 2 by third of the resources. It is nothing but the ratio. Did you get the logic here? Did you get the logic, guys? It is nothing but the ratio.
Yes.
Okay. Now let us further try to understand this from a different scenario. Let us say I have one single CPU. Forget how many shares it has created. But because I told you if I have 100 rupees, how many shares I can create? It depends on my unit value. Okay. So we need to forget that unit value. Now here I have created two resource pools. Finance pool CPU shares 2000, marketing pool CPU shares 1000. What is the meaning of it? Finance pool is going to get 2 by third of the resources. Marketing pool is going to get 1 by third of the resources. Again, out of finance pool, I have created another two pools. Finance test virtual machines 1000, finance production virtual machines 2000. That means from the finance pool, finance test virtual machine is going to get 1 by third, finance production virtual machines is going to get 2 by third. Again, from the marketing finance pool, marketing test virtual machines is going to get 1 by third, and marketing production virtual machines is going to get 2 by third. Now, when I compare marketing test virtual machines with the actual CPU, then how much shares does marketing test VM resource pool is getting?
1 by 6.
So 1 by 6, that means 11%, right?
11.
Is 33, 1 by third of 33 is 11% from the actual CPU. Got it? So this should be the calculation guys. Don't get confused with the number of shares there. It is the ratio of what is being distributed. Clear? Clear with the concept? Now in a moment I am going to show you how to create resource pools. Just give me a moment guys. Give me a moment.
Vijay, there's a background noise, man, like phone sound.
Right, guys. Apologies. Yes, guys. Fine. So let me show you how to create this resource pools. And here, resource pools can be created on host or on a cluster. There are only two places where you can create a resource pool, either on a host or on a cluster. So if your host is a part of a cluster, then I can create a resource pool on a cluster. Let me right click. I'll find this resource pool, new resource pool, and here you need to name this resource pool based on the department, maybe based on application, based on whatever the naming convention is used in your infrastructure. Let us say this is finance pool. Now here are CPU shares. Guys, low 2000 shares, normal 4000 shares, and high 8000 shares. Now it depends, or you can also customize. Maybe you don't want to use this, maybe you want to give 6000 shares. You can give this. Reservation.
Is the
Minimum.
total number of shares for a resource pool?
See,
Oh, sorry.
it depends. The shares I cannot decide. Okay, it is always in the ratio part. Fine. However, this is how it is calculated. For low, it allocates 2000 shares. For normal, it allocates 4000 shares. And for high, it allocates 8000 shares.
But
Okay.
we don't know
So,
total number of shares,
yes.
right? That is
Yes, that we can't do. Fine. So here, if I give high shares, then this particular finance pool is going to get high shares. Now after that, reservation. Reservation would be in megahertz. So here, if I want to give reservation, let us say I want to reserve 2000 megahertz, approximately 2 gigahertz with this resource pool. And limit. If I set it to unlimited, then it can, wherever it requires, it can reach up to the maximum. Fine. Alright, expandable reservation. If you say check this box, then that means yes. If you uncheck it, that means no expandable reservation. That's it. We find memory is low, normal, high. Okay. So here depends on your infrastructure. Maybe CPU shares normal would be okay, and memory shares high would be okay for you. So you can give this. The same way, reservation. Let me say that I want to reserve approximately 6 GB to this resource pool. Okay. The same way, unlimited. These are the parameters or attributes by which I can control resource pool. So I have created a resource pool. So this is nothing but a logical abstraction. So where are these resources coming from? From the cluster. Okay. Now from this, again, I can further create resource pools. Quota beneath the quota. You can create finance, production virtual machines or development virtual machines in that way. Again, you can allocate resources to that. Now, then once we allocate resources, once we create a resource pool, then we can drag and drop the virtual machines, which can be a part of this particular resource pool. Let us say these are the virtual machines which are to be a part of this resource pool. You can just drag and drop certain virtual machines into it. In this way, you can group multiple virtual machines and resources. All these virtual machines are going to share the resources from this resource pool, finance pool. So this is how we create resource pools and allocate resources to specific group of virtual machines based on department, application, and criticality, so on and so forth. However, this concept of resource pools is used in very large infrastructures where you have some thousands of machines and you want to allocate resources to specific group of virtual machines. You can use it, and specifically this can be used in clouding and cloud infrastructures. Suppose you have created a private cloud or a public cloud, then these resource pools will come handy. You can divide and allocate resources to certain group of virtual machines. So this is how we create resource pools and manage resource pools. Fine. Now,
Mujib,
yes,
I
yes.
don't understand here, like how resource pool works, like how resources are divided here. Like, I mean,
See,
we allocated resources from cluster finance
yes,
finance
yes.
pool, right? So we
So
have
these
only
virtual
one
machines,
resource pool.
yes,
So we have
whatever
only.
the
Mhm.
whatever the virtual machines I place in this resource pool, these virtual machines are going to utilize the resources from what I have configured on this resource pool. Okay. So what are the resources I have configured here? I have given high shares, okay, and I have reserved 2 GB to 2 gigahertz CPU power to it and 6 GB RAM to it. This one would be reserved, and these virtual machines are going to get the resources from this pool. Okay, that means I'm creating a quota out of the actual resources.
So out
Okay,
of how many, like, if we given 8,000 here, right? So
yes.
out of how many 8,000 goes to finance pool? Because
Don't
there
go with
are
the
remaining
numbers.
VMs too, right? We
Yes,
have remaining VMs which are not part of resource
resource
pool.
pool. Yes.
So
See,
resources has to divide it between non-resource
I
pool
gave
and
8,000 shares to it. Fine. What are the remaining shares? The other virtual machines are going to utilize it. Okay. Now, for example, let me go to this virtual machine. Let me go to this virtual machine. So right click, go to edit settings, resources. You're seeing the shares.
yeah.
What is here? Normal. I told you ESXi by default considers every virtual machine as equal and it will allocate certain amount of resources to it. How much shares is it allocating to this virtual machine? 2000 shares. Got the point? So every virtual machine is having its shares. Okay? Every virtual machine is having its shares. Okay? You go and see on every virtual machine you find these shares. Whether you specifically allocate or not. What ESXi will consider every virtual machine as equal. Every virtual machine as equal and it is allocating resources.
What exactly you mean by share?
See, the entire resources are converted into shares.
What kind of resource? Is it like any
CPU.
particular element? CPU?
No, specifically, these are the resources. CPU, memory.
Okay.
The CPU is converted into shares, memory is converted into shares. And these are allocated to individual virtual machines in the form of shares.
Oh, what do you mean by
Yeah.
shares, Soji? What do you mean by shares?
A share is a portion allocated to you.
Oh.
Got the point? Now suppose uh, property. Okay. Now property is being distributed among hires in your family, let us say, or in our family. Suppose my grandfather has property and he has 5 sons, and he wants to distribute this property among these 5. So he's going to allocate shares out of it, maybe 20% each to everyone. You understood this? So
Yeah.
shares is the amount what you get. Okay. Here, in the terms of virtual infrastructure, specifically virtual machines, it's a guarantee that minimum amount of resources are assigned or allocated to virtual machines. That is what is a share. Yeah. You have the concept?
Yes.
Yeah. So this is how we can allocate specific resources in the form of shares by creating resource pools and manage and divide and allocate resources to group of virtual machines. Now then comes the monitoring part, guys. Guys, in any infrastructure, monitoring plays very important role, and specifically in virtual infrastructure is very important, very, very important, because we know that virtual machines running on hosts are already sharing the resources, and sometimes your virtual machines will fight or compete for the resources, and there might be resource contention. So
Hello? Hello?
monitor the resource usage. There are guest operating system tools as well as VMware tools. The guest operating system tools can be your task manager in Windows, or the performance monitor of Windows, or it can be the top command on Linux, or you can use third-party free application like IOmeter. In the same way, there are certain tools which VMware also provides, VMware vSphere, for example, vCenter performance charts, ESXi logs, and there is a command called ESXstop or RESXstop by which you can monitor the resources, especially the CPU, memory, disk, and network bandwidth. Now, what we are going to monitor and how to interpret the data and what to interpret the data. Let us see one after the other. Now, interpreting the data from monitoring tools. The first question, if your CPU is constant, how to find it out? Is your virtual machine CPU constant? That means the CPU which has been allocated to your virtual machine is not sufficient for processing. Maybe that application requires more CPU power. Or whether the host is unable to provide that CPU to your virtual machine. Now, how to interpret that data? For example, if the virtual machine is CPU constant, then most probably your task manager on a Windows machine will show that the CPU usage is continuously high, touching 90 or 100% for a continuous period of time, for a longer period of time. And most probably at that particular time, your virtual machine's performance would be pretty slow because your CPU usage is quite high and it is taking time for each and every task to complete. So you have observed in the task manager. Now, at the same time, you need to also observe the CPU real-time usage from the vCenter performance charts. Now, let me show you how to observe it. On the vCenter server, on every object, you find a tab called performance. Okay, in this tab, you find overview tab and advanced tab. The advanced tab will give you the real-time usage right now. Suppose I want to monitor DC Zoom. This is my virtual machine. And let us say its CPU is constant. And if I go into the task manager of this virtual machine, it is showing high usage continuously. So I need to also check vCenter performance charts and find out CPU real-time usage. How you can observe it, how you can monitor it. Go to the performance tab of this virtual machine. Go to the advanced section. And here you find CPU real-time usage right now. Okay, you see this, the percentage right now is 0.219. So if this virtual machine CPU is constant, maybe it will show you a graph continuously high, touching 90 to 100%. And if you see the average usage, it is continuously for 90 to 100%. Then you need to also observe since how long this continuous usage is. It is for the entire day or for a specific period of time. If it is for a specific period of time, you need to also understand what is happening inside that virtual machine. Is there any installation going on? Are there any important tasks going on? If nothing is happening, still the CPU usage is high and that period is for a continuous period of time, then most probably the CPU your virtual machine CPU is constant, and that is an indication that your application requires more processing power. Fine. Now, sometimes there might be a scenario where your host is unable to provide the CPU to your virtual machine. If that's the case, then most probably this would be the scenario where all the virtual machines would be CPU constant. Not the specific virtual machine, but all the virtual machines will be reporting high CPU usage. This would occur when your host is unable to provide CPU to your virtual machines. That means a lot of load on the CPU, on the physical CPU, and your VM kernel is scheduling the virtual machines to run on CPUs, and every virtual machine will be having high CPU usage at that particular time. And how to interpret that, whether the virtual machines, all the virtual machines are CPU constant. Then you need to go to host, and then go to the performance tab, go to the advanced section, and here CPU real time will be seen here continuously. The CPU usage of this host would be high, maybe 90% or 100%. Right now it is on average less than 1%. Okay. Now, how to see whether all the virtual machines are CPU constant? You need to go to the chart options, and here you find stat graph per VM, and you can select all the VMs by clicking on all and click on OK. Now, once that is done, you find the stat graph for each virtual machine. Right now, this color is for VC Zoom, and this here it is for VC Zoom. And if you see this, these are the usages of these virtual machines. Okay, all right. So in this way, you can see the stack graph. If all the virtual machine stack graph is high continuously, as you're seeing the stack graph, you're seeing all the virtual machine stack graph is high continuously, maybe showing 90 and 100%, then that is a clear-cut indication that all the virtual machines are CPU constrained because your host is unable to manage the CPU load balance. That means there's a lot of load on the physical CPUs. That's the reason why all the virtual machines are CPU constrained. If there is DRS in place, then DRS will manage this. It will try to migrate virtual machines to some other host where there is CPU available. Even after that, if there is a lot of CPU constraint, then most probably you need to add another host in your cluster or migrate certain virtual machines to some other host where there is enough CPU resources. So this is how we interpret the data. Now then comes the most important virtual machine memory constraint. Is your virtual machine memory constraint? Then you need to observe it from the operating system tools, task manager. Let us say task manager is showing 90 to 100% of the memory usage. Okay, and then you need to also check the memory real-time usage on a specific virtual machine. Let us say this is a machine.
Hello?
Hello? Hello? Hello? Is Mujib is there?
Disconnected maybe again.
Let's some chit chat, man.
Hi, how are you?
I'm fine, thanks.
Today you left?